Woohoo, math. All right. More 3D geometry. Here we go. We've been doing surface area. We were doing surface area of prisms. We did rectangular prisms. Then we did triangular prisms. And now we're going on to surface area yet again, but this time surface area of pyramids. Pyramids were the other type of three-dimensional shape that we looked at as this unit began. And here we go. Um, you might recall a pyramid. Let me bring this down. A pyramid is a shape that has one base. Prisms have two bases, but pyramids have one base, and across from that base is an apex. It's a point right up here. Let me get my pen. Here we go. Where all of the faces meet up at. So this is a pyramid, and we're going to be finding the surface area of pyramids today. In particular, we're going to be working with rectangular pyramids, pyramids that have a base that is the shape of a rectangle. What is surface area? If you laid your cereal box flat, it's all the space that the writing takes up on the box, the flat stuff. We're not talking about volume, so stop doing length times width times height. I've seen some of you do that in your work. Don't do that. We're not talking about volume yet. We're talking about surface area. There's many more steps to surface area than there are volume. So pay attention to what you're finding and what you're doing. Don't rush. And here we go. So first, we need to visualize what does a pyramid, a rectangular pyramid, look like laid out flat, aka what does its net look like? So this kind of reminds me of like a flower opening up, like maybe not, but I kind of see that visualization in my head. It's like unfolding, the petals are opening, and then here it is laid out flat. So there's the base, the one rectangular base. And another fact about all pyramids is that the non-base faces, the other sides, always have to be triangles. So no matter what, you're always going to be finding the area of a base and then the area of some triangles and adding it all together. So let's jump right into an example. Find the surface area of the rectangular pyramid. All right, so I'm first going to give you the net. I'm not good at nets, so instead I just make a list of all of the faces and then I add all of those together once I'm done. So the first thing I'm going to do is the base itself. In this case, the base, that rhymed, is a rectangle. It's actually a square. I know that because it's 7 inches or 7 meters on all sides. So the area of the base, length times width, is 49. Next, I have to find 1, 2, 3, 4. 4 sides. So side 1, side 2, side 3, and side 4. They're all triangles, and let's just get their dimensions down. So I'm going to call this one side 1, this one side 2, this one side 3, and this one side 4. Let me clean this up a little bit. There we go. All right, so side 1 is this triangle right here, and what I notice is that it gives us the height is 10 from the bottom to the tippy top, straight line, that's the height. So the height is 10, and the base, all of the base sides are the same, right? They're all 7. So the area of this triangle is half times base times height, which is 35. Now, for this pyramid, all of the triangular faces are exactly the same. They all have a height of 10 and they all have a base of 7. So to save yourself some time, you could, instead of writing side 1, side 2, side 3, side 4, and doing the same exact work 4 times over, you could just take that 35, which represents one of the sides, and you could just multiply that by 4, quadruple it. Wow, that's a really bad 4. And then you'll have all 4 sides added together. My pen does not want to work today. So 35 times 4 is 35 plus 35 plus 35 plus 35. That's 170. Excuse me, 140. So what does 140 represent? I'll make sure to write this down. This is all 4 triangles. It's not just one of them, it's all 4 of them. And that's just, instead of me doing the same work 4 times. Anyways, let's put it all together. Surface area is equal to all of the sides added together. So the base was 49, and then all 4 triangles added up to 140. So in total, my surface area is 189 square meters. There we go. It's just like what you'd been doing with prisms. It's just a different shape now. And I'll do one more just because it's good to see. This one also has a base that's a square. Anytime you only see one measure on the base, we're going to assume that all 4 sides have the same length. So this makes a square again. With that being said, the base is a square, and it's 8 feet by 8 feet, which has an area of 64. And then the sides, in this case, again, every single side happens to be the same. This is not always going to be true. Let's say that this was not a square base. Let's say it was a rectangle. Let's say that this was 8 and this side was, I don't know, 10. We're pretending for a second. That would make one of these a 10 and the other one an 8. And that would mean that not all 4 triangles are the same. So you have to pay attention to what the measures are and which triangles have which base measure. Anyways, let's wrap this up. We've got all 4 triangles have a base of 8 and a height of 11. Height of 11. So how do you find the area of a triangle? Same thing we always do. Half times base times height, which is 44. You could also then quadruple that. Why? Because we have got 4 triangular sides that are all exactly the same, so all of them are 44. So 44 times 4, and then you can add everything together. 44 times 4 is 176. That's all 4 sides. And then wrapping it up, the surface area, the area of all the surfaces, is equal to the base plus all 4 sides, which is a nice, even 240 square feet. All right, that's it for today. You've got some practice problems. Pay attention to what the measures are. Do your best. Ask questions if you have any. And woo, math.